Hello, we are about to begin Activity 2, and Activity 2 is going to be all about geometric sequences and series, and we will also do the first two lessons in Activity 2. Today we have Lesson 2-1, which is geometric sequences. So our learning targets are going to be to determine whether a given sequence is geometric as opposed to arithmetic. We want to be able to find the common ratio of a geometric sequence instead of a common difference like arithmetic. And then finally be able to write an expression for a geometric sequence and then also calculate the nth term or any term. So just like the first activity, we're going to start with a problem, and I will read it to you. It says, Meredith is designing a mural for an outside wall of a warehouse that is being converted into the Taylor Modern Art Museum. The mural is 32 feet wide by 31 feet high. The design consists of squares in 5 different sizes that are painted black or white as shown below. All right, our first question is going to have us fill out a table. It says, let square 1 be the largest size, so that would be the ones at the top, and square 5 the smallest size. For each size, we're going to record the length of the side. We're going to do the number of squares of that size in the design and the area of the square. And that'll give us a couple of sequences to look at. So in square number 1, we want to know the side length of that square. Well, since we know it's going 31 by 32, so if this is 31, there's going to be, or if this height is 31, that means this width has to be the 32, and there's actually 32 of these little squares there. So like those are each going to be worth 1. So the side, then we would have to figure out the rest of the sides of the square. So if we just work our way up, we can see that 2 of these will make the side of that square, and that 2 of those would make the side. So that's going to be 2 plus 2, that'll make 4. And then of course 2 of those is going to make a side of the next square. So 4 plus 4, which is going to be 8. And then finally, 8 by 8, 8 plus 8, which would make our 16 for the side of the biggest square. And then we can double check that that does actually add to 31, which it does if we do 16 plus 8 plus 4 plus 2 plus 1. Basically the side of the square number 1 then would have to be 16. Square number 2 is going to be the 8. Square number 3 is 4. And square number 4 is 2. Square number 1 is just 1. All right, now the number of squares this time of that size is what we want to get next. So in our first square, which we can see there's only 2 of those 16 by 16 squares, so there's 2 of those big squares. And then there's actually 4 of the next size down, and then there are 8 of the next size. Finally, the ones with the 2 squares, there are going to be 16 of those. And then like we said at the beginning, there's 32 going across the bottom. So there's 32 of those 1 by 1 squares. So that's the number of squares we have of those sizes. Finally, the area of each one. So for the big square, 16 by 16. So we're going to do side squared or side times side to give us area, of course. So 16 times 16 is actually 256 feet squared. And then 8 by 8, 64. 4 by 4, 16. And we have 2 by 2, which is 4. Finally, 1 by 1, which is 1. So now that we filled in the information, we have a bunch of sequences we can look at and that we'll use. So let's go to the next page. All right, so in the next page, they ask us to work with our group and come up with some patterns. And so what we're going to do is think about the patterns that we notice in that table. So if we look back at that table again, I see as the square number increases by 1, I actually see that the side length of the square is decreasing. Looks like it's decreasing, it's dividing by 2. So that's one pattern I noticed. So I could write that down as the square number increases by 1. The side length is divided by 2. Okay, and I do see some other patterns. Okay, I also noticed that the number of squares doubles each time. If I look at the second column, the number of squares actually doubles. It goes from 2 to 4 to 8 to 16 to 32 as the square number increases. So, you can write down whatever you notice in those patterns. So it says each column forms a sequence of numbers, and I'm going to list the 4 sequences so we can see that and we can look at each one of them. So in the first column, that was just the square number. So we saw that was 1, 2, 3, 4, and 5. And then we also noticed the next one we saw was I saw 16, 8, 4, 2, and 1. Okay, and the third pattern I see is the 2, 4, 8, 16, 32. And finally, I see the area pattern, which was 256, 64, 16, 4, and 1. Okay, so those were just the 4 columns. Are any of those sequences arithmetic? Why or why not? Okay, so thinking back to proving arithmetic, remember they have to have a common difference. So if I subtract any 2 terms, I should get that same number. So the first sequence, 2 minus 1 is 1, and 3 minus 2 is 1, and 4 minus 3 is 1. So that one I know is arithmetic. That's 1, 2, 3, 4, 5 is definitely arithmetic. And if you look at the other ones, we don't have that common difference when we subtract our terms. So those are going to be representing our new type of sequences, which are going to be our geometric sequences. So that sequence was arithmetic because there is a common difference. And if you remember, that's because if we take 2 minus 1, we get 1. And if we take 3 minus 2, we get 1. And 4 minus 3, we get 1. And so on. All right, so now we're going to introduce the geometric sequence. We'll go to the highlighter. And a geometric sequence is a sequence in which the ratio of the consecutive terms is a constant. We're going to be looking for a common ratio now. Think of it almost like a multiplier. The constant is called the common ratio and is denoted by a little r. So on the side here, you're also going to notice that you have a review of common difference versus the common ratio. So remember, common difference in an arithmetic sequence, subtract the preceding term from the following term. And then for a common ratio, we're going to divide any term by the preceding term. And that's how we're going to find common ratio. So let's look at the sequences then that are considered geometric. So we're going to have the first of all, the side of the square. So we have the 16, 8, 4, 2, 1. And we also have the number of squares, which was the 2, 4, 8, 16, 32. And finally, we also had the area of the square, which was the 256, 64, 16, 4, and 1. So we have those 3 sequences that we would consider geometric. And now we're going to look for the common ratio for each of the sequences. So for the first sequence, I see I would have to take an 8 divided by a 16, and that's going to give me 1/2. So for that first sequence, the ratio is going to be 1/2. Okay, so it's going to be a fraction between 0 and 1 if the sequence is decreasing. Now for the second, we're going to look at, again, we're going to do some division for the number of squares. So it's going to be, if I do 4 divided by 2, I actually get 2. So the ratio here is a whole number 2. So a number bigger than 1. And we can see that looks like it's a multiplier. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And our very last one, if I take, you could do any 2 terms. If I don't feel like doing the big ones, I can just look at, I can look at 4 divided by 16. And I know that gives me 1/4. So my ratio here is going to be 1/4 for that sequence. So that's how you find a common ratio. So now let's put that in a formula form on the next page. And so it says use A sub n and a sub n minus 1 to write a general expression for a common ratio r. So our common ratio r is going to be found by doing a division of a term with its preceding term, or the term before it. So if the term is a sub n, we would want to divide it by the term that came before it, which is a sub n minus 1. Okay, so let's take a breath for a second. And we've just spent some time now just looking at what a geometric sequence is and defining it. And we're going to work our way to coming up with a formula for it. But we also are going to take a second and look at the graph of it like we did look at the graph of the arithmetic. So that's what we're going to do for question number 5. So we're going to actually take a look at a graph. So to get us ready for that, let's go to the side and make a grid. And so what you're going to want to do on the bottom, since there were we'll just go, I think there were, 5 terms in the sequence. So when we go across the bottom, it's not going to be, that far. We can just do, let's kind of make our grid like this. So our term number, there were 5 terms. So we'll just go 1, 2, 3, 4, 5 for the 5 terms. And then depending on what we're graphing, we're not going to go up to the area, so we don't have to go up to 256 or anything, but let's go up to 16. So we know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and I'm going to run out of room. I should have moved my axis down a little bit, but we'll make it work. Up to 16. So we're actually going to do 2 different graphs here. We're going to plot the square number sequence by plotting the ordered pairs term number and square number. So I'm going to, the first one, I want to do this ordered pair. I want to do term number and square number. So, I'll write that one. I'll keep that one in blue so that matches. So the first term and then the square number, the first term was 1, and then the square number was 1, so 1, 1. Oops, let me get out of the highlighter for a second there. Get rid of that. There we go. Go back to the pen. Okay, so if we remember that column, and I can go back and look at it real quick, square number and term number. Well, term 1 was square 1, and term 2 is square 2, and term 3 is square 3, and so on. So this one's going to be linear. Look at that. We'll have 1, 1, and 1, 1, and 2, 2, and 3, 3, and 4, 4, and 5, 5. That was the only arithmetic sequence that we were given. So we can see that that one is linear, which we're actually going to check, look at that in part C. But then, if I go back to the highlighter, the next one that they want us to look at is they want us to graph the term number with the side of the square. Okay, and we know that one was different. So if I'm going to write that one, I'll do that one in green. And so term number 1, remember that one was huge. That was 16. So term number 1 is way up there. And term number 2 divided by 2. So that was 8. So that one is right here. Not looking very linear. Number 3, term 3, divided again by 2, and that got us 4. So term 3 is 4. So I'm not seeing a common difference this time. Term 4 divided by 2 again, and it gave us 2. And then one more divided by 2 for term 5 gave us 1. And so that is not a linear sequence. That is a curve. And so just getting a chance to look at the difference between the arithmetic graph, which is linear, and the geometric graph, which is not going to be linear. So the linear function sequence was the sequence that was the arithmetic, because there was a common difference. All right, so the next group of problems is in the check your understanding, and so I'm going to leave those, of course, for you to try. Sometimes I run through them, but I don't want the video to get too long, so I'm going to leave some of those for you to try yourself. So we're going to go down now and develop the formulas that we're going to need to use to find the number of terms. So when we get to number 9, the first thing they're going to ask us for is the recursive formula. Remember, the recursive formula needs the term before the term you want. So for a recursive formula, you can find a term by taking that common ratio times the term that came right before it. Okay, so that'd be great. If you always do the term before it, you can get the next term. Okay, but typically that's not the case. So we're going to develop the formula for finding any term. And that's going to come on the next page. Okay, so this will go a little quicker because we did this once before. So we're going to take a geometric sequence that they gave us right here. Okay, and first we're going to start by identifying some things. So it says find the a sub 1. So a sub 1, of course, is the first term 4. And the R term would be the common difference, which of course we get by dividing. So if I take 8 divided by 4, I get 2. So my common ratio is 2. So the first term was 4. The second term is 4 times 2, which gave me 8. Well, the exponent would have to be 1 then. 4 times 2 is 8. Well, 4 times 2 to what power would give me 16? Well, the next term would have to have a different exponent because I need it to be 4 times 4 now. To get that 16. So 4 times 2 squared. Okay, so that exponent actually, is going to increase. If I want the fourth term, I'm going to need 4 times 2 cubed. And the fifth term, 4 times 2 to the fourth, and so on. And then the sixth term would be to the fifth, and then of course they jump to 10. So it's 4 times 2 to the ninth. Okay, and then we get those numbers. Of course, just multiplying by 2 is what you could think of it as. And so, of course, that would be 32 and 64 and 128 and 2048 would be the continuation of that sequence. So this is going to allow us to write what we call that explicit formula. And the explicit formula will help us find any term. So to do that, all we have to do is to get any term, a sub n, we need the first term, a sub 1, and then we're going to multiply it by the common ratio, but we're going to use the exponent as the term that we want minus 1, so the preceding term. You can see a sub 10 was 4 times 2 to the ninth, and a sub 6 was 4 times 2 to the fifth. So that is our formula, and that's going to help us find any term, and we're going to try that and practice that right now with question number 12. So I need to find those things. I need to know the a sub 1, and I need to know the common ratio, and what term I'm looking for. And if I have all those things, then I can find any term. So it says use the formula to find, and in question A we want a sub 16. Okay, so if I want a sub 16, then I am going to need a sub 1 times r to the 16 minus 1 power, or 15th power. So that's what I'm going to want to do. So now I just have to fill that stuff in. So to find a sub 16, I know my first term, I can see it, it's 1. And my common ratio I need to find. So let me do that really quick. So r is, let's just do 2 divided by 1, which is 2. So my common ratio is 2 to the 15th power. Use my calculator to do 2 to the 15th power, and your 16th term will be, I think that's 32,768 using my calculator, of course. Okay. Now part B, they want us to find a sub 9. So we'll go on to that one. So again, I like to just write it out. If I need a sub 9, then I need a sub 1 times the ratio to the n minus 1 power, which is 9 minus 1, or to the 8th power. Now the common ratio this time is going to be a fraction, so we just want to be careful. I'm just going to do 64. I like the smaller number. 64 divided by 256. And when you do that, you could get a decimal, but we tend to stick with the fractions on this one, so that actually ends up being 1/4. So my a sub 9 is going to be the first term, 4,096, times the ratio of 1/4 raised to the 8th power. Now remember, you do have to use order of operations. So you have to take 1/4 to the 8th power before you multiply by the 4,096. But you can do it all on your calculator. So you want to practice that until you see that you get about 0.0625. And I will double check that, because remember, first you have to take the 1/4 to the 8th power. And then once you get that, you have to multiply by 4,096. And it kind of gives you a messy number. And then you could change it to a fraction if you want to. So a sub 9 would be 1/16. So, we might want to practice how to get from a decimal to a fraction because, depending on how the answers are listed, you might want that fraction. So we'll talk about that in class. All right, so that takes us to the very end where you have all your practice. So it would be up to you then to spend some time doing the practice problems from all the Check Your Understanding questions and the lesson practice. So you can pull up the answer key when you're ready and check your answers. And be ready to talk to me in class if you have any questions. Thanks so much, everybody. Have a great day.